So in this practice, two objects are connected by a light string that passes over a frictionless pulley as shown in the figures. Assume that the incline is frictionless and take the lower case of the m is 1 kilograms and the capital M is 5 kilograms and theta is 30 degrees. Find the acceleration of the object, the tension in the strings, and the speed of the object 3 seconds after they are released from rest. So first of all, we'd like to draw the free body diagrams. This is theta, is 30 degrees. And the object, capital M, this is heavy ones, and light ones, is connected by the strings. This is 5 kilogram. This is 1 kilogram. And the two object is connected by the light string. So tension force is acting on the both objects. Same magnitude of tension force is acting. And the gravitational force is acting. Gravitational force is acting. And the normal force is acting on the large object. Normal force. Now we successfully draw the free body diagrams. Now we are ready to write the equation of motion. Then we could find out the motion of these two objects. The big ones, actually this object has heavy ones compared with the blue ones. So red one is we expect is moving down. So we write down the acceleration in these directions. So acceleration of the big object and the smaller object have to be the same because the two objects is connected by light strings. Then we are ready to write down the equation of motions. But before that, it's better to decompose the gravitational force for the heavy object. This gravitational force is considered as the sum of the two forces. So this, and then if you consider this triangle, this corresponds to thetas. Then this gravitational force is mg sine theta. This equals 1 over 2 mg if the theta is 30 degrees. This component is mg cosine theta. This square root 3 over 2 mg. Then we'd like to write down the equations of motions. So the m is mass times accelerations. So in this direction, force is 1 over 2 mg. It comes from the gravitational force minus tension force. This is the first equation. For the m, blue block, mass acceleration is same, a equal t minus gravitational force. It's the opposite direction with respect to the tension force. So we have two equations. We use these two equations to find out the acceleration and the tension force. So if you sum up the first equation and the second equation, you have m plus ma, and the tension force is cancelled out. 1 over 2m minus mg. So accelerations is 1 over 2m minus m over m plus mg. So if you substitute all the values, it becomes 1 over 4g. So it becomes 2.45 meter per square second. This is accelerations. For the tension force, you can use equation 2. T equal ma plus g. So you can substitute this here. So 5m over 4g. So it becomes 12.25 newtons. This is a tension force. Last one, the speed of the object. We have already discovered acceleration is a 2.45 meter per square second. The velocity is obtained acceleration times times. So you can substitute 3 seconds. And the acceleration is here. Then it becomes 7.35 meter per second. This is the answer to this practice.